modern data center, 76% of the traffic is east-to-west traffic. New application deployment architectures with multiple endpoints, dozens of interdependencies, and rapid mobility are becoming the new normal. Identifying the application dependencies and gaining visibility into the flow patterns involved to minimize latency between endpoints and avoid top-of-the-hierarchy congestion is extremely important and difficult. Cisco Tetration Analytics Platform is the most powerful data center telemetry and analytics platform in the industry. It is the only solution that can capture telemetry information from every packet, every flow at line rate, and deliver actionable vision insights into what's happening inside an infrastructure to help you understand the flow pattern of the application dependencies with real-time and historical analysis. Turbonomic Tetration integration leverages Tetration analytics to retrieve real-time flow information and use Turbonomic network control module to localize the network traffic. So in this demo, we have built a few VMs on top of Cisco UCS, and in some of the VMs, we have installed Tetration software sensor so that when the VMs start to communicate with each other, the Tetration analytics can receive the real-time flow information. So for this endpoint 1 and endpoint 2 VMs, we're just setting two different servers. We have started to use a tool called iPerf to generate network traffic between each other. So the IP of endpoint 1 is 137.13 and the endpoint 2 is .14. Let's take a look at Tetration. In Tetration, it is extremely easy to gain the visibility of application dependencies as well as flow. Let's take a look at the application side. So this is the endpoint 1 VM. If we click from endpoint 1 VM, we can drill down what is the endpoint and what are the neighbors of this endpoint 1 VM. If I click the cluster, we can identify the communication pattern between endpoint 1 and other VMs. And currently, endpoint 1 only talks to one of the VMs, which is the endpoint 2 CentOS. If we click on the Flow tab, it's also extremely easy to identify the flow information in real time by Tetration to gain the real visibility. So let's identify which is the VMs that we're looking for. So this is the flow between endpoint 1 and endpoint 2. And you can see all the information about how much flow has been sent between the two VMs, how much is the flow of packets, and how many packets has been received. In Turbonomic, we have already added all the targets from the Turbonomic UI, including the vCenter, Cisco Tetration, and Cisco UCS. After that, you get immediate visibility for the entire IP stack, from applications all the way down to the physical chassis. So for every UCS domain, we created one entity called dpod to represent all the physical hardware that is closely connected to each other. For example, all the blades in the same UCS domain. And for endpoints that are communicating with each other, we created vpod, which is relying on the Tetration flow patterns and application dependency mapping. For example, this endpoint and endpoint 2, which we see from Tetration. Now let's look at the VMs. From Turbonomic, it's extremely easy to see the resource consumption across different dimensions, from compute to storage to network. The flow information here we see is from Tetration. After we get the value from Tetration, we categorize the flow into three different levels: in-provider flow, in-dpod flow, and cross-dpod flow, so the Turbonomic market analysis engine can parse them differently. In-provider flow means that the VMs that are communicating with each other are in the same server, which means the communication will be latency-free. In-dpod flow means that the two VMs are in the same dpod, i.e. UCS domain, but not in the same host. And cross-dpod flow, as you can imagine, indicates that the VMs that are communicating with each other are in two different dpods. For example, one in public cloud and one in private cloud. So the latency of cross-dpod flow will be huge. Since the two VMs are in the same Cisco UCS domain and they're consuming from two different servers, so what we see here is the in-dpod flow. What Turbonomic can suggest is, based on the resource consumption across different dimensions, we identify that you can move this virtual machine endpoint 2 CentOS from host 22 to host 21 to prevent the congestion. And the congestion is the flow congestion on host 22 due to the network traffic between endpoint 2 and endpoint 1, which is what Tetration is telling us. From Turbonomic, you can always execute this action directly, and you can choose to automate the actions from Turbonomic to set your data center to an entire complete autopilot. To summarize, Turbonomic collects the real-time endpoint flow information from Tetration to provide real-time monitoring of flows at different levels based on the VM's location. To create dpod based on the UCS domain, to create vpod based on the flow matrix to help user understand which endpoints are communicating with each other. Based on this information, Turbonomic is able to localize the network communication by moving a VM across hosts to improve the network latency, or by moving an entire vpod across dpods to prevent the dpod congestion. Thank you for watching this demo.